In this video, we will learn how to find distance of a point from a line. Here we will first try to mentally walk through the steps to solve this and then finally analyze the expression we get. So let's start. We have a line and a point and we need to find the minimum distance between them. The minimum distance is always the perpendicular distance between the point and the line. If we draw any other distance between the line and the point, it will be greater than the perpendicular distance. So let's consider this line, which is perpendicular to the given line and passes through the given point. So basically, if we can find this point and then find the distance between these two points, we will get our answer. But for that, first we need to find this point. Can we write the equation of this line? We have already learned to do that we need at least two information about this line. The first obvious information we know is that it passes through this point. Second information we know is that it is perpendicular to the given line. We can find the slope of the original line by looking at its coefficients of x and y. Slope of a linear equation like this is minus coefficient of x by coefficient of y. Thus, the slope of the line is minus a by b. And so, the slope of the line perpendicular to this will be b by a. This comes from the fact that product of slopes of line perpendicular to each other is minus 1. Now, as we have two information about this line, that are a point through which it passes and its slope, we can write its equation using point-slope form. The next step is to find the point where these two lines intersect. How can we do that? If this point has coordinate xy, then x and y will satisfy both these linear equations. Hence, we get this expression. By solving this, we will get the values of coordinates of the points where these two lines meet. The last step is very simple. Now we just need to find the distance between these 2 points. We have already learned that distance between 2 points can be found using Pythagoras theorem, where base of the right angle triangle is difference in x coordinate and perpendicular is difference in y coordinate. The final expression for the distance between the points x1, y1 and the line ax plus by plus c equal to 0 comes as mod of ax1 plus by1 plus c divided by a square plus b square. This is very useful expression we should remember. Now suppose we have a linear equation representing a line and we want to find the perpendicular distance of this line from the origin and the angle the perpendicular line makes with x-axis. How can we do this? The first part is straightforward. We will use the expression for finding the distance between a line and a point, which in this case is 0, 0. This comes out to be this. Let's again look at the slope of the original line. From this we can find the slope of the perpendicular, hence tan omega, which is negative of inverse of slope of original line. Now if we apply our knowledge of trigonometry, we can find sin omega and cos omega, which comes out to be this. Now in the equation of L1, if we divide each term by a square plus b square, the expression of the same line comes to be this. Here we should notice that the coefficient of x is sin omega and coefficient of y is cos omega. And the last term is nothing but perpendicular distance of the line from the origin. This is called normal form of the line. We can directly use this form when we know perpendicular distance of a line and the angle the perpendicular makes with the x-axis. It is also advisable to remember the algorithm we have used to find this, especially the expression of distance between a point and a line.